Hello viewers, in today's class we are going to discuss yet another important and very conceptual problem from definite integrals involving signum function, right? So here we have to find the value of this integral, that is integral from half to 2, and the integrand is signum of log of x, right? So here we have the natural log, right? So here we'll try to find out the value of this definite integral using the definition of log function, and then we'll see the definition of signum function, right? And moreover we'll also see the graph of signum of log x. So let us start. So let us call this integral as I, right? Now here we can take this integrand or this function as f of x. So we have f of x is equal to signum of log of x, right? Now see, we know that signum of say p is defined like this, that is signum of p takes the value plus 1 whenever p is greater than 0. Signum of p is 0 whenever p is equal to 0, and signum of p takes the value minus 1 when p is less than 0, right? So here for p we have a log of x, right? So let us first define signum of log of x, right? So signum of log of x can be defined as signum of log of x takes the value plus 1 whenever log of x is greater than 0, right? And when signum of log of x takes the value 0, it means log of x should be equal to 0, right? So p is 0 and p is log of x, and signum of log of x is negative 1 whenever log of x is less than 0, right? So we have followed this definition of signum function to define signum of log of x. So now let us extend this definition, right? So we can now write signum of log of x takes the value plus 1 whenever log of x is greater than 0, right? And log of x is greater than 0 whenever x belongs to the interval 1 to infinity, right? Or in other words, we can say that when x is greater than 1. So when x is greater than 1, then log of x is greater than 0. So log of signum of log of x is plus 1, right? Okay, now signum of log of x is 0 when log of x is equal to 0. So log of x is equal to 0 whenever x is equal to 1, right? Because log of 1 is equal to 0, right? And signum of log of x is negative 1 when log of x is less than 0, right? So the logarithm of x is less than 0 whenever x belongs to the interval 0 to 1, right? Or in other words, we can say that when x is greater than 0 but it is less than 1, or x lies between 0 and 1. So log of x is less than 0 or it is negative when x lies between 0 and 1, right? So to solve this integral, the important thing is to define signum of log of x, right? So once we have defined signum of log of x, we can now split this integral I as a sum of two integrals. So now see here, the limits of integration are from half to 2, right? So let us represent these numbers on the real number line. So here we have minus infinity, here we have plus infinity, and here we can take half, and here we have 2, right? And between half and 2, here we have say 1, right? And here we can take 0, right? And we have to integrate from half to 2, and between half and 2 we have the number 1. So when we write this integral I as half to 1, it means all the values of x lie between half and 1, right? So here we have a signum of log of x. So the important thing is that we have to split this integral as a sum of two integrals, keeping in mind the definition of a signum of log of x, right? So when we go from half to 1, it means all the values of x lie between half and 1, right? So in that case, signum of log of x is minus 1, right? And then we have 1 to 2, and here we have signum of log of x, right? And in this case, x lies between 1 and 2. It means x is greater than 1 and less than 2. So here we have signum of log of x is equal to plus 1, right? So in the first integral, the value of x lies between half and 1. So signum of log of x should take the value minus 1, because here x lies between 0 and 1, right? So now we can write I is equal to half to 1, and here we have minus 1 dx. And in the second case, or second integral, x lies between 1 and 2. So x is greater than 1, right? So when x is greater than 1, signum of log of x is plus 1. So here we have 1, here we have 2, here we have plus 1 dx. So now we have two simple integrals. Integral of minus dx is minus x. Limits are from half to 1. And here integral of dx is x, and this is 1 to 2, right? So now we can substitute the limits and we'll take the difference. So we have 1 minus half here, and here we have 2 minus 1, right? So I is 1 minus half is half, so here we have minus half, and here we have 2 minus 1 is 1. So this is 1 minus half, that is half, right? So viewers, the value of this integral is equal to half, right? Now let us take the graph of signum of log of x. So now here we have the coordinate axis. So this is x-axis, this is y-axis, right? Now see, here f of x is signum of log of x, right? So let us take f of x is equal to y, right? So here we have y. So y is equal to 1. Y is equal to 1 when x is greater than 1, right? And y is equal to 0 whenever x is equal to 1, right? And y is equal to minus 1 whenever x lies between 0 and 1, right? So to draw the graph of signum of log of x, we have to plot these three lines. So let us first take this one, right? So when x is 1, then y is equal to 0, right? So here we have x is equal to 1 and y is equal to 0. So this is the coordinate 1 comma 0, right? Okay. See, y is equal to 1 when x is greater than 1, right? So see, here we have x is equal to 1. So we'll start from this point. So here we'll take an open circle to show that x is not equal to 1, right? And y is equal to 1 is a line which is parallel to x-axis, right? So we can draw a line like this, right? So this is the line y is equal to 1, right? Okay, now see here we have x lying between 0 and 1. So here we have x is equal to 0, here we have x is equal to 1, right? And both the points 0 and 1 are not included. And we have the line y is equal to -1, and y is equal to -1 is again a line which is parallel to x-axis, right? So here we can draw the line y is equal to -1 like this, right? So this is the line y is equal to -1, and here we'll write open circle. Here also we'll write an open circle, right? So this is the graph of signum of log of x, right? So here we have uh, that is y is equal to 0, and here this line is y is equal to 1, this is y is equal to -1, right? And moreover, if we wish to draw the graph of y is equal to log of x in this graph, then we can draw it like this, right? So the graph of log x is like this. So here we have 1, and the graph of log x goes like this, right? So this is a rough diagram. So this graph shows that this is y is equal to log of x, right? So viewers, this is how we can solve this integral, and we can draw the graph of signum of log of x.